Ladies and gentlemen, a very good day to all. My name is CheeFai. I'm from the Universiti Tunku Abdul, Malaysia. I'm very honored to be invited by the World Federation of Engineering Organizations to be part of the contributor for the online open course that organized by WFEO's Committee on Engineering or for Innovative Technologies, or CEIT. The online open course is aiming to popularize the overall theoretical framework of innovative technologies to the public and emphasizing its key role in promoting sustainable development. I would like to share about a topic that related to Internet of Things for the Sustainable Development Goals. I have been very actively volunteer myself to the various NGOs in Malaysia, in ASEAN, Asia and the Pacific and the world. In 2015, world leaders agreed to 17 global goals, officially known as the Sustainable Development Goals, or SDGs. The global goals is looking to end the poverty, to fight against inequality, addressing climate change, environmental protection, education opportunity, to look into the health opportunity, job opportunity, to raise up the social protection, and etc. There are three main focus under the SDGs. First, it look into the economic growth. Secondly, it's about social inclusion. Thirdly, it's about the environmental protection. In total, there are 17 Sustainable Development Goals that the United Nations would like to focus on. For today, I would like to share about the Internet of Things, or IoT. IoT technologies is contributing to the improvement of citizens' quality of life and companies' competitiveness. Some of the benefits of IoT, such as to reduce the cost, especially related to the manufacturing, better use of natural resources and preservation. IoT able to improve the product quality. IoT is able to increase the regulatory compliances and etc. So what is IoT? Actually, IoT is a sensors and actuators embedded in physical objects, are linked through wire and wireless network, often using the same internet protocol that connects the internet. This is the history of IoT. It's interrelated to the telecommunication. It started with the invention of the telephone. Then in 1960, under the Nikola Tesla said that IoT is a futuristic concept in 1960. And then 1974, the internet was born. In 1984, the first domain name was introduced. And then in the 1989, the internet as a network of connected devices in consumer homes was proposed. The first website online in 1991, and then the multiple websites and system online is happened in 1995. During the 2001, iPod was launched, and then 2007, iPhone, the smartphone era was born. During 2015, there are about 15 billion connected devices in the world, and 2020 there will be 50 billion connected devices, and so on. So this is the history of the Internet of Things. So how does IoT work? In this slide, it shows the major component of IoT. From left, you can see that there are things or device as a base. And then this thing or device you connect to the gateway, either through the wire, hard wire, or wireless in the wireless network. The data will transfer to the gateway. From gateway, it will transfer to the cloud with the data. The data also to transfer to a system where the analytics is happening there. And then the data, the result will show to the consumer or client via the interface. What is the smart devices and sensor? Devices and sensors are the components of the device connectivity layer. So these smart sensors are continuously collecting data from the environment and transmit the information to the next layer. In general, this is the lowest level that represent the sensors. For the communication, this sensor can, through the different wireless protocol like LoRa, Wi-Fi, Zigbee, Bluetooth, and transmit the data to the gateway. For the gateway, it manages the bidirectional data traffic between different networks and protocol. Another function of gateway is to translate different network protocols and make sure interoperability of the connected devices and sensors. For the cloud, Internet of Things, or IoT, creates massive data from devices, applications, and users, which has to be managed in an efficient way. IoT Cloud offers tools to collect, process, manage, and store huge amount of data in real time. Industry and services can easily access this data remotely and make critical decisions when necessary. So in here, I list down a few worldwide famous cloud services, such as Amazon Web Services, Alibaba Cloud, Google Cloud, Public Cloud, and others. For analytics, analytics is the process of converting analog data from billions of smart devices and sensors into useful insights, which can be interpreted and used for detailed analysis. Smart analytics solutions are inevitable for IoT system for management and improvement of the entire system. For user interface, these user interfaces are the visible, tangible part of the IoT system, which can be accessible by user. Designer will have to make sure a well-designed user interface for minimum effort for users and encourage more interactions, because what they want is information, the result. This is the concept, this implication about the IoT versus Internet of Everything versus machine to machines and others. IoT is the most popular term in describing the new interconnected world. And Cisco has been driving the term of Internet of Everything, IoE. Intel initially called in the embedded Internet. Other terms that have been proposed but don't mean are exactly all the same are such as M2M, which is machine to machine communications, Web of Things, Industry 4.0, Industrial Internet of Things, Smart Systems, Pervasive Computing, and Intelligent System. For M2M, this term has been used for more than a decade and is well known in the telecom sectors. M2M communications had initially been a one-to-one connection, linking one machine to another. But today's explosion of the mobile connectivity means that data can now be more easily transmitted via a system of IP networks to a much wider range of devices. Next one, Industrial Internet of Things. The term Industrial Internet is strongly pushed by GE. It goes beyond M2M since it not only focuses on connection between machines, but also includes human interface. For the Internet of Things, IoT has yet a wider reach as it also includes connection beyond the industrial context, such as wearable devices on people. For the Internet as we know it, the Internet is a fairly small box right in here in this graph. It connect only people. For the Web of Things, in the left hand side, the Web of Things is much narrower in scope as the other concepts, as it solely focuses on software architecture. For the Internet of Everything, or IoE, it's still a rather vague concept. IoE aims to include all sorts of connections that one can envision. The concept has thus the highest reach. About the Industry 4.0, the term Industry 4.0 that is strongly pushed by the German government is as limited as the industrial internet, in which as it only focuses on manufacturing environments. However, it has the largest scope of all the concepts. Industry 4.0 describes a set of concepts to drive the next industrial revolution. That includes all kinds of connectivity concepts in the industrial context. However, it goes further and includes real changes to the physical world around us, such as 3D printing technologies or the introduction of a new augmented reality hardware and software. In this slide, I would like to show you the application of the IoT to better and to achieve the SDG. Number 1, no poverty. IoT can be used to tackle fuel poverty through better awareness of consumptions and helping people make smarter decisions. It means that IoT can be used to gather the data, to pull the data about the awareness for the awareness of consumption. Okay, so the people can make the smarter decision. Secondly, IoT can be used to improve social housing through monitoring conditions in a smart building. For SDG 2, Zero Hunger, IoT can be used to improve the yield from harvesting and storage. Next, it also can use to improve the existing distribution network of the food and leverage cost-effective real-time data harnessed from the cold chain infrastructure with track and trace capabilities to make sure the food is fresh and safe to consume. Next one, the IoT can be used to improve the food purchase habits in affluent countries to minimize the waste. Next one, the IoT can be used to extend the shelf life of produce because the IoT is able to monitor the product, the food in real time. And lastly, the IoT also can enable the surplus food to be shared with others. For the SDG number 3, it's about the good health and well-being. IoT can be used to remove inequalities in health. No matter where is the patient, the IoT can be used to monitor the condition of the patient as well as to gather the data, health data from the patient. IoT can be used to enable the virtual clinics, the wards, and hospital. IoT can be embedded with the sensor and become the wearable biosensors that are able to monitor the patient 24 hours by 7. And it also can enable the smart thermometers that are able to feed the data to the center and then enable to the group people to really understand the condition of certain health issue. And also used to connect the inheritors and also enable the remote health monitoring. As I said, no matter where the patient is or are, is also able to monitor the health, okay, and assisting the elderly as well. SDG 6 about the green water and sanitation and life below water. IoT is enable to improvement of safe and affordable water for all. Okay, it's also related to the water security. IoT can improve the water quality by reducing the pollution, eliminating dumping, and minimizing release of hazardous chemicals and materials. Having the population of untreated wastewater and substantially increasing recycling and safe reuse globally, because IoT can use to monitor the condition of the water, okay, in real time. And the IoT also able to improve water use efficiency and as well as the remote monitoring water related ecosystem. For SDG 7, IoT is about the affordable and clean energy. IoT enable the improvement on the monitoring, control, and integration of power sources. For the example, it enable the increase of the efficiency in renewable energy sources through improved management of their wearable output. In the SDG number 9, it's about the industry, innovation, and infrastructure. IoT creates opportunities for new and innovative products and service model, because IoT is just a component, right? It needs a lot of innovative solution, okay, idea from the floor that enable IoT to be used to improve something. And IoT able to track and manage asset remotely and in real time, allowing a more efficient use of people for the better quality of lifestyle of people, and predict when parks will fill using sensors so they can be replaced before this happen, reducing the downtime as well. And it will help employees make better decisions about the tasks they are doing by providing relevant real-time information, as well as automate repetitive and predictable processes through smart IoT system. For the SDG 11, it's about the sustainable cities. So IoTs transform city infrastructure through intelligent buildings and transport infrastructure, air quality monitoring, and smart energy and water network. Secondly, IoT able to enable the shared information between widely dispersed groups of individuals through technologies such as shared activities trackers, which help people to stay connected and feel part of the broader community. About the SDG 12, is related to the responsible consumption and production. IoT able to reduce waste from manufacturing and from shorter and more responsive supply chains, because it can monitor the quality of the product from time to time. IoT enable to track the provenance of products and their constituent components across the supply chain and their lifetime, so that products are more easily reused and recycled, supporting circular economy models. Next one, as part the SDG 13, climate action. IoT enable the monitoring of ecosystem and the natural environment using webs of connected sensor, as well as it can improve energy efficiency through smart devices that can provide a low-cost way for people to conserve energy by monitoring home temperatures, varying temperature by room, and controlling temperature when out of the house. Right. SDG 15 is about the life on land. IoT can be used as a real-time monitoring and alarm system for the freshwater ecosystem, to monitor the freshwater ecosystem, to monitor the desertification and degraded land, to monitor the biodiversity and natural habitat, deforestation and degraded forests, as well as the mountain ecosystem. In next slide, I would like to share the application of IoT in various industry. In this slide, I'm showing that IoT in farming. So IoT-based technologies and sensors have been applied in many agriculture bases across China. Okay, because they know that IoT can help to test, alert, analyze, and make adjustment to the growing environment of plants, specifically saving water and fertilizer while reducing labor costs. At the end, it's improved the crop yields, right? So it will reduce the issue, the pain point of the farming, right? Also address the field of the SDG goal. Next one, IoT also can use to combat the desertification. This is an example from China. Okay, in this application, SAG has joined hands with Alipay on Ant Forest, a private company, right? So Alipay is China's largest private sector entity. This group is China's largest private sector's anti-desertification initiative. Okay, the aim to save the planet from the desert encroachment. So the digital technologies such as Internet of Things, right, are harnessed to connect the consumers with some of the distant land in northwest China. So the trees are planted in the desert regions to reconstruct the fragile arid ecosystem while inspiring people to conduct a greener lifestyle and reduce their environmental footprint. In the next slide, in China, Beijing, okay, IoT also used to manage the air pollution. Okay, why? It's due to during the China growing, okay, in the past 3 decades. Due to the industrialization in China and the economic growth, the China need to pay for the very heavy costs of the environmental degradation. Right, the average air pollution level of PM 2.5 was 18.4 UG over meter cube in Beijing in 2015, as compared to the healthy guidelines set by the World Health Organization, which is 10 UGs over meter cube. In response to the environmental challenges, the government of China is setting aggressive policy targets to reduce energy intensity by 58% from 2010 level and cap carbon emission level by 2030. So partnering with the companies, Beijing developed a system to help authorities pinpoint the type, source and level of emission and predict air quality in the city. They applied a hybrid data assimilation and big data analytics So the system implements high-frequency data from various sources, including ground monitoring stations, radar satellites, etc. Additionally, quantum computing technology realizes adaptive optimization and self-learning of various physical and chemical models, which enhance the prediction accuracy significantly. So from here, with the data that retrieved from the various station, the monitoring station, right, the government or city or Beijing city government can able to make a good decision, okay, that related to the air pollution, and then they know what to do to better the air pollution in the city. So lastly, it's the end. I would like to quote the word by the Charles Darwin. He said that it's not the strongest of the species that survive, nor the most intelligent, but the one more responsive to change. So I hope that with the application of the innovative technologies such as IoT, we hope that the technologies is able to achieve, enable the countries to achieve the sustainable development goals in total. And then that's all for my presentation and sharing. Thank you for your listening. Bye-bye. Goodbye.